Okay, so example 2 says, pull it up. So example 2 says to calculate the mass of precipitate. Okay, so precipitate again means a solid that is produced. Okay. So calculate the mass of precipitate when 200 milliliters of 0.018 moles per liter iron sulfate is mixed with 175 milliliters of 0.204 moles per liter ammonium phosphate. Okay, so they've given us some information again, but the first thing that we need to do, guys, is we need to write a balanced chemical equation. And the question is going to become, well, what are we going to be writing it for? So this question has told us that two things are reacting. It said iron sulfate and ammonium phosphate are reacting. Now, they've given us concentrations of both, which means both of them are solutions, which means they're aqueous. So iron sulfate, it said iron 2, okay. Black fading. Iron 2 has a charge of 2 plus. Sulfate has a charge of 2 minus. So the 2's, when they drop and swap, are going to cancel out. So we get FeSO4 aqueous. Ammonium phosphate. Ammonium has a charge of 1. Phosphate has a charge of 3. Okay? When these react, it's going to be a double replacement reaction. So the metals are going to switch, or cations. So iron is going to switch with ammonium. So we're going to get iron 3, PO4 2, and ammonium NH4 sulfate. Now, I can check my solubility table to determine which of these is going to be the precipitate. So I can do that. I'm just going to tell you, anything with NH4 is always aqueous, 100%. Okay? So it's aqueous, which means this is my solid, this is my precipitate. So the question wants me to find the mass of this chemical right here. If I want to find the mass of something, I need two things. I need molar mass. All right, I've got a chemical formula. I can do that. And I need the moles. All right, well, I don't have the moles yet. I have the molar mass. That's fine, or I can find it. But I do not have the moles, okay? So that's what I'm concerned with. But have they given me other information? The answer is yes. They've given me information about two different chemicals. They've given me information about iron sulfate and ammonium phosphate. And I can use that information to find the moles of something else. So let's try that. So iron sulfate, they've told me that the volume is 200 milliliters, or again, liters, 0.200, and the concentration is 0.118 moles per liter. If I have volume and concentration, I can always calculate moles. Okay. C times V. Again, whenever you're doing stoichiometry problems, guys, chances are you're going to be calculating moles in some capacity. Okay. So these problems, guys, 0.0236 moles. These problems are exactly the same as what we did not exactly the same. They're pretty much the same as last week. Last week, I would have given you guys the moles here, and we would have rode the molar coaster to get over here. However, in this week's lesson, we now have to decide which moles we're going to use because they've given us two chemicals. So for ammonium phosphate, they said the volume was 175 and the concentration, so again, 0.175 liters. Concentration is 0.204 moles per liter. find the moles. And I already see something that we haven't done yet. So I'm just gonna finish this and then we'll go to there. 0.204 times 0.175. Okay, 0.0357. Okay, I found the moles of both of these. Now, the next step that we need to do to decide which one is the limiting reagent is divide them by the coefficients. Look up at that equation. I have not balanced this chemical equation yet. I got ahead of myself. So we need to go back and balance this out. So we could pick any chemical, but let's pick iron. There's 1 iron over here, 3 irons here. Okay, I need a 3 there. Now I have 3 sulfates. Okay, so I need to put a 3 here because I only had 1. Well, now I have 6 ammoniums. I've got 3 here. I need to put a 2 there. 2 phosphates, 2 phosphates. Good. Okay, that means to figure out what the limiting reagent is, marker dropped. I'm going to divide this coefficient is 2. I'm going to divide that moles by 2. Coefficient is 3. I'm going to divide this by 3. Okay, so down here, I'm going to get N is equal to 0.01785. Okay, that is my final reacting moles for this. And then 0.0236 divided by 3. I'm going to get N equals 0.00786 ... moles. Don't round that number. Okay, so ladies and gentlemen, which one of these chemicals is going to be our limiting reagent? Okay, again, it's a limiting reagent question because they've given me information about both reactants and they've asked me about the product. Which one of these is going to run out first? The bigger number or smaller number? Answer is smaller number. So I'm going to finish the molar coaster, okay, with these moles. Now watch this. The molar coaster is divide by where you start, multiply by where you're going. I have already divided by where I start, so all I have to finish now is multiply by where I'm going, which is a coefficient of 1. Again, I'm riding the molar coaster to the precipitate because it's the solid. So I divided by where I start, multiply by where I'm going. So I'm going to get 0.00786 ... moles. Figure out the mass. Okay, I need the molar mass. Molar mass of iron phosphate. Okay, I'm going to get 3 irons, so 55.85 times 3. I'm going to get 2 phosphoruses plus 30.97 times 2. And then I'm going to get 8 oxygens. I get 357.49 grams per mole. So when I do this and I sub in that information, 357.49 grams per mole. Don't have enough room here. I'm just going to write moles down here. Again, don't round that mole number, guys, because there's some other digits that we want to consider. Times, so now multiply them together over here and to get the mass. All right, and you're going to get 2.81 grams. 3 sig-digs in the question based off volume and concentration, 2.81 grams. So again, this is the final answer, 2.81. Last week, I only would have given you information about one chemical, and you would have had to divide by where you start, multiply by where I'm going to get it over to the precipitate. Now, in a limiting reagent question, you have 2 chemicals that are both reacting. You have information about both of them, and you need to use the one that runs out first because it's going to determine how much is produced, which in this reaction, theoretically, should be 2.81 grams.